Welcome everyone to another Best Paper interview from River Publishers. Today I'm with Anand Prasad, the Editor-in-Chief of our Journal of ICT Standardization. And today we are announcing and discussing another one of the best papers from 2021, which was awarded to Intent-Driven Closed Loops for Autonomous Networks. We have some of the authors with us to chat about the paper. But just to start with, Anand, can you please introduce the journal a little bit and what it covers?
Sure. Thanks, Philippa, and thanks everyone for joining today, making time. It was some effort to put our schedules together, but really appreciate that. Journal of ICT Standardization, close to 10 years old now. We'll be soon celebrating that. The idea it started with is that standards are used everywhere. I still remember back then when I talked about standards to my son, who was still a kid actually. He touched the switch and said, that's also a standard over there. But they're really everywhere, and education of that, knowledge of that needs to be brought to everyone in the society. And with that, myself being in ICT side, let's put it that way, and the others around me, we started off this Journal of ICT Standardization to bring information about and knowledge about standards or technology that can be is moving towards standards that does make the scope bigger, and also about what standards entails to publish such kind of papers in the journal and bring it to wider public. And as you know, currently it's available on River website to anyone who wants to access. Yeah. In very simple terms, Philippa, I put it that way. Of course, I can always expand.
Yeah, definitely. Thank you. And of course, there will be a link to the journal with this video for anyone who's interested to see more. Yeah, thank you, Anand, and welcome everybody else. Thank you for joining me. Congratulations on winning the prize for one of the best papers from last year. Could you perhaps please start by introducing yourselves and the paper a little bit? Pedro, would you like to go first?
Yes, right. My name is Pedro Henrique Gomes. I'm a senior researcher working at Ericsson, and my research focuses more on management systems and automation tooling for the 5G and beyond 5G networks. And as part of my activities, I'm involved in some standardization groups, and one of them is this FTZS that I think we're going to talk a bit during the interview. And in this group, I have contributed to some specifications related to closed loop automation and intent-driven management. And this is also part of the topic of this paper.
Maybe I should go then next. I don't know. Jörg Niemöller. I'm expert of analytics and customer experience at Ericsson. And I'm involved in these topics from actually three different sides. First of all, the research and development work for autonomous networks, zero-touch automation and intent-based automation. Then for the same topic, standardization work. So I'm the author, for example, of the TM Forum standard documents on intent. And the third part is introducing all this into products. So I'm sitting somewhere in between the research organization and the product organization to ensure that these concepts, these forward-looking concepts, get sooner or later into our roadmap, into our products.
Swarup?
Okay. Hi. Yeah, please go ahead.
Yes, okay. I am Swarup Mohalik, a principal researcher in Ericsson Research, and I am working towards a smart, intelligent network for 5G, 5G beyond, and 6G through the use of cognitive technologies. And my contribution has been towards the intents in particular, and several ideas about conflict detection and resolution in the closed loops. Thanks.
Yeah, hi, I'm Magnus Buhrgard. I'm with Ericsson as well, and I'm leading the engagement in open source, the ONAP, Open Networking Automation Platform, where Ericsson is contributing to the open source code. And I'm also active in this FTZS group, and I'm the rapporteur of the intent work item that we are just about to conclude. Okay, thanks.
Thank you, Magnus.
Yeah, I think. Yeah, now I think I can talk a bit, introduce a bit the paper itself. So as we I guess you have already noticed that we talk a lot, this group, about closed loops and intents. And this is one of the main objectives of this paper. So we proposed this methodology that combines these two different, very important concepts for the autonomous networks management. So we have closed loops and intents. And closed loops, it's already a very old term, and it's a concept that has been used in many different industries, but it's basically this enabler that allows you to remove humans from the actuation of the network. So the main objective is to automate lots of the network tasks with this concept of having an autonomous entity, a feedback loop that is able to monitor the state of the network, to derive insights, analyze what the network needs to be changed, and also make the decision. So the autonomous to write scripts that substitute the human beings, but rather that or this concept that is able to make decisions and to learn also about the previous decisions and make better decisions in the future. So that's the overall concept of closed loops. And then we have, on the other hand, intents. And intents, it's a more recent topic or more recent idea, but it has been formalized, especially in the standardization groups, as this specification of requirements, goals, and constraints that you give to a system. So with intents, you provide what is the goal of the closed loops. And with closed loops, you have the brief to make your automation solution. And that's basically what the paper tries to do. So you use the closed loop concepts and the enablers of closed loops that were already defined in this ZSM architecture. And we put intent on top of it to make the systems even more autonomous, to allow the systems to learn the requirements, the needs from the users, and also the needs between different systems. So we try to make the intents as a universal specification of the closed loop goals, and also to abstract the interactions that may happen between different closed loops within the ZSM framework. That's the overall idea of the paper, what we tried to bring in the concept. And technically speaking, what we did was, or what we proposed was, to extend this ZSM framework with support of intents, because at the time that the paper was written, intents was not an enabler that was already supported by the framework. And with intents, with closed loops, we try to facilitate the integration of these autonomous entities that we need to have in the network management. So that's more or less what the paper covered.
Okay, thank you. And you mentioned the ZSM framework. Could you expand on that a little bit and how it's particularly useful for this kind of automation?
Yeah, sure. So this ZSM framework is a management framework that aims at automation. So first, the ZSM framework is defined by this group, ZSM, and ETSI is the main standardization institute in the world in this area of information and communications. And ZSM, it stands for Zero Touch Network and Service Management. So the main objective is to provide a full end-to-end automation architecture for different types of networks or different types of services, not only 5G, but our focus is, of course, 5G as the most recent technology and the focus of most of the companies in this group. But the architecture framework itself is agnostic enough to be applied in IoT, in different industries, so it's very generic. This framework is, first of all, a service-based management framework. This means that we do not the functions or what are the entities in the management system that you need to implement, but we focus more on the services and what are the capabilities that need to be exposed so that systems can provide this standardized end-to-end solution. So we have specified the architectural framework with a specification. It's called ZSM 002. Everyone can find on the web, and it has a lot of management services and data services that can be implemented in different what we call management domains. So management domains are boundaries of management that can be either administrative boundary or a technological boundary, like access networks, core networks, transport networks, that you need to manage, and you need to put these pieces together to create the end-to-end service. So ZSM we can think as kind of a glue that puts together the services from different domains. So the scope mainly of ZSM is this end-to-end layer, and we do not reinvent the wheel. We do not try to define things for individual domains, but rather we find what is the best standard. For example, in access network, in core network, we have a reference to 3GPP. In transport, we have a reference to IETF and so on. What we want to have in the ZSM is this generic set of enablers and generic set of services and capabilities that should be used by different domains to make these domains more automation friendly. So it's a very modular, flexible, extensible framework. It has enablers for closed loop automation, data-driven management, artificial intelligence. Specifically in closed loops, when we wrote the paper, we were specification on closed loop enablers, and it provided a set of enablers for governance and for coordination of closed loops. So closed loops is, as I said, kind of the main enablers for automation. So you need to have closed loops everywhere on the end-to-end layer as well as in the individual and management domains. But we have not at that time studied how to integrate, for example, as an enabler in this automation. The same framework is already a very comprehensive framework, but still there are things that we are trying to solve, like pieces of the puzzle that we are still trying to put together. And this paper, one of the objectives of this paper was to explore another step towards this like full end-to-end autonomous management system.
If I may, Philippa. So thanks, Pedro. Of the sake also for our audience and also myself, can we take one concrete example, some use case, and explain I say ZSM, and I understood there is closed loop there, but you have added intent on top of that, and so how that intent part comes in.
One use case, one example that we actually have a specific one specific specification for that is the network slicing. So in 5G, so network slicing is intrinsically a multi-domain use case, because you need to create an end-to-end network slice. You need to involve core network, transport, access network, even some IoT application domain. So you need to put these things together, and we have analyzed in the industry, in the landscape, what are the best standardization for each one of these different domains, and we have set this common set of enablers in the ZSM framework to allow these domains to be automated, or to become to create this full end-to-end service automatically, or based on some automation tooling. And as part of this enablers, this tooling, we have closed loops. So closed loops, they will take care of many different tasks. We can say that basically closed loops, they can make the networks and the domains more autonomous, in the sense of having this self-star capabilities, like self-configuration, self-healing, self-optimization, self-protection. And the closed loops, they will in each one of the domains. And you will also have closed loops running in the end-to-end layer, taking care of all the different services that are put together that need to be decomposed from the end-to-end service that is requested, probably from business system, from end user, or even from a third party, another vertical industry. And intents is the specification of the requirements of these services. So intents can be seen as the main language or the way of requesting a service in an abstracted manner. So you can, if you have the knowledge, you can request for example, the service instantiation from different domains. And if you know all the nuts and bolts of each of the domains, you can do that kind of manually using the services that are provided. Or you can just specify an intent and send this intent to the end-to-end layer, and this intent will be decomposed into another intent for each of the different domains. And this intent, they will be kind of the main input to the closed loops that are running, because the closed loops need to know what are the goals that it needs to achieve. And closed loops, they can be more generic in the sense that you can change also the behavior of the closed loop. You can change the goal from optimizing different metrics, and this can be set by means of the use of intents. So that's how we put everything together.
Would anybody else like to add their thoughts? I'm thinking particularly on the role of intent-driven closed loops and kind of how they can help overcome some of the challenges associated with automation.
Yeah, I can start. I think the intent is the glue between different domains and different industries, if you will. So intent in sort of in short, you could say, is you know what you want, but you don't know how to ask for it. So the information you need to control or to steer another domain is maybe not that you don't have that, or it takes a long time to learn, and you don't want to read the manual, so to say. So if you're interested in like communication as a manufacturer or a transport company or something, you want to use the benefits of 5G, but you don't know exactly all the terms and all the interfaces and everything. Then you can express your intent, what you want to get out of it. And then you can have this kind of autonomous system where you figure out what is the best fit for your needs. So yeah.
I think this is one of the most important aspects here. I mean, we have two domains. One domain has requirement that the other domains need to fulfill. The first domain having the requirements has no clue about the technical details of the other domain, and it should not have, in order to have a sane separation of concerns. Intent is strengthening the separation of concerns to a very, very big degree. So no domain needs to know how another domain is solving a problem, but it only needs to know what it wants to be achieved. And this is what an intent is formulating. And therefore, we have now a control loop between these two domains that are intent-driven, which can adapt very well to different use case scenarios, can extend very well, and most importantly, keeps the human out of the loop, because everything is formally modeled. The semantics are clear through the intent model. And the separation of concerns is highly important for future integration of AI into this loop, for example.
Yeah, and how important is it keeping you mentioned the whole point is trying to keep the human out of the loop, which can someone talk about like kind of why certain industries would want that and how this would help them achieve that?
Yeah, the summary of that is we expect that future use cases will simply not allow to have humans in the loop. The requirements for how reactive a system needs to be is beyond human capabilities. Okay. The volume of operational tasks we expect to be beyond human capabilities. So a human in the loop is actually a very big burden It's not only a cost factor. I think it's not a cost factor at all. I mean, it is more a capability factor.
Okay.
So, but it is also very tricky to completely hand over the control to a fully automated system. So these systems must not just follow predetermined recipes, because these systems must understand what they're doing, because this would allow them to basically check if what they're doing is correct, if the policies that they're applying are the correct ones. Without that, they might just follow a recipe that is, because of situational change, not applicable anymore. But this is the all that they have. So, and intent is giving them that. Intent is giving them a notion about what is supposed to be good and what is supposed to be bad in terms of outcomes.
Okay.
So, and this allows the system to make very intelligent decisions on its own right, and also in new situations that were not pre-thought and predetermined by a human policy developer, for example.
Okay, thank you. Sorry, Magnus, did you want to say something?
No, yeah, just a small comments there. I think in telecommunication we have a tradition of being more deterministic. I mean, we configure the systems and let them run. And then we pick up reports and we see what happened, and maybe we change the configuration and the structure. But I mean, lately we've seen, especially in radio access networks and with the self-organized networks, that this is not good enough. We have to be much more agile. We have to be more aware of what is happening in the network, and we have to measure and analyze what's happening, and then change the system much faster. And I think we come from a tradition where we are based on human sort of intelligence, and it's not enough anymore.
And agility in a zero-touch context, meaning in a non-human context, basically means that the system has to understand what it's doing. It has to be able to adapt itself in an intelligent way, also to new situations, without all the time referring back to a human, that the human is making the decision for it.
Yeah.
So a system that is just replicating human decisions is much less capable in this respect than a system that is able to understand what it's doing, what the effects of it is. We usually call this decision by utility maximization, and intent is the notion of utility in this respect. This stresses the important role that intent is having in this kind of operational scenarios.
Yeah, if I may add, Philippa, when we say human completely out of the loop, they don't vanish away from the scene. They are there in a supervisory capacity, or in the role of adding some more knowledge and kind of guidance for the systems. So for the day-to-day agile, reactive kind of decision making, we don't want the human to be there.
The humans still produce the artifacts the system is using. They can still produce policies. They can still produce machine learned models. So they do all that, and they also monitor the performance of the system, and they would change the artifacts the system has available. But this is all offline activities. This is all activities that observe what the system is doing and optimize it. It is not involved at all in the online decision making anymore.
I think you can make a reference to an aircraft. If the pilots aboard, they're in control of the aircraft, but there are multiple sort of closed loops that are running and sort of taking care of all the parts that needs to get the aircraft to fly in a controlled way, and. So there's still sort of a human factor, but it's on the supervising part.
I mean, for security purposes, the human is always standing by to step in if something is happening or that needs its intervention. But in this respect, the more intelligent system will make this much more seldom that this is necessary, and therefore the very big metric of an autonomous system, of how autonomous and capable it is how often does this happen that the human still has to step in online operation, and how often does the system really refer to the human or escalate to a human decision. And if this is not happening, then you have an autonomous network, which is then the end result of the work here.
Okay, thank you everyone for kind of clarifying that a little bit for me. Anand, did you want to add something?
No, I really appreciate the explanation. This helps everyone to understand better, and I just want to add that I heard the background of the group who wrote the paper, and I can understand why it's a so beautiful paper. Yeah, people are coming from research all the way to product level, yeah, and in between the standards part and taking care of R&D, what we call, and taking them towards product as well. So that's all the combination that has made it happen very nicely. So yeah, I appreciate the explanation given already, Philippa. Yeah.
Okay, thank you. And on that note that you mentioned, could someone briefly kind of expand upon what the role of standardization is in this? Perhaps Pedro?
Yeah, sure. The standardization, well, it's important in any multiplayer environment or anywhere where you have different companies that produce products, because they need to work together at some point. But in the end-to-end management solution, it's even more important. And if you think about automation of end-to-end service, it's crucial to have enablers or services that are standardized, because usually if we think about, for example, 5G network slicing, you have a very heterogeneous environment, and you're going to have multiple vendors for each one of the domains that you are dealing with. So these vendors, they have their own products. The products, they need to work together. So the products, they will have their own closed loop solutions themselves. So you need to make these closed loops to work together somehow in harmony. So standardization of specifically closed loop automation is very important, because you need to provide this fundamental or this foundation for the end-to-end automation solution. And if you have this heterogeneous environment with multiple vendors, multiple technologies, some of these technologies, they are still legacy, they are not automation friendly. So you need to, as much as possible, push for the standardization. So I think here standardization plays like a crucial role, as it also plays in many other scenarios. Standardization of intents is something new. It's something that we are striving to get. Maybe Jörg can also talk a bit, because he's one of the leaders from our group in this sense. I think standardization of intents itself is quite important.
And maybe I can step in here. When we talk about the role of standardization in this context, we have the research side, where proof of concepts for individual research questions are investigated, but this doesn't deliver you a working network. This delivers you how to solve this particular problem and this particular problem. Then on the other side, we have a product landscape or a market landscape, which is highly heterogeneous, where you have solutions from different vendors that need to interact with each other. They need to understand each other. And now when we introduce a concept like intent, that is supposed to be on the interface between domains, this is definitely or has a very high potential to be on these interfaces that are multi-vendor. So what we need now is standardization that is developing reference architectures that introduce what functions and need to be developed, and also then what are the information models that need to be used. And when I talk about information models, I'm talking about introducing vocabulary to formulate intent with commonly agreed semantics, and that is what standards are basically doing. In intent modeling, we actually extend the way that modeling works quite a bit, because we are going for semantical ontology models rather than just information models on API. So the API development that intent entails goes one step above, and this is related again to the system needs to understand, and this indicates semantic models. This paper that we have written constitutes somehow some fundamental work in this direction, and in the meantime we have seen now that standardization organizations made a lot of progress in defining reference architectures, In TM Forum, for example, I'm working currently on the 3rd version of the intent common model, which is the vocabulary for intent formulation. And this summer we have published already an intent API in that forum. And as I said, this paper is the fundamental work that allows all these kind of achievements in standardization to happen, which of course then means we know how to do products now.
Yeah, I think it's also a matter of trust. I mean, you have to persuade the network operators, the owners, to trust automation. And then you have to have a certain amount of transparency. You have to tell that we're using the same terminology, that we have the same models, and that they can trust their sort of health of their networks on automation and in intent.
Yeah, and with that, Magnus, I guess if you're saying the operators, so we're talking about telecom industry, then their requirements are also brought into standards, and
yeah, correct. And they also know that the vendors are using the same kind of standards. That also gives a stability to the solutions, and that will mean trust in the systems.
Yeah, in the paper we provide a very, it's a toy example on how to use this semantic modeling that Jörg just mentioned, and we show small examples of how to use the RDF as this common framework for having ontologies as the main type of modeling for intents, and where these ontologies can be used in the end-to-end use case. And as Jörg said, this is kind of a fundamental work, because when we wrote the paper, we were about to start to push these ideas into standardization. And at this time, right now, there are a lot of work that has progressed and has been accepted by standardization groups, such as TM Forum.
Maybe I can make a point here why ontologies are important versus the traditional information models. When you do a traditional information models, of course, you specify the semantics also, but it is more documented rather than modeled. So this means the model introduces some vocabulary, some IDs, some elements, and then a documentation is providing the semantics so that a developer can read it and write a respective code. When we have an ontology, we not only have the information elements modeled, but we have the entire semantical framework around it modeled, which means that the implementation can take a step back and don't need to be specific anymore. We can use general purpose machine reasoning in order to draw conclusions from the model and implement our logic this way. And this provides us a much more data-driven and therefore much more adaptable decision-making processes. Because the code doesn't change just because you introduce more use case domains. It's the same kind of inferencing that you do, but the models are changing. I think this is an important step forward for the entire industry, because this is not the common way that telecommunication is doing APIs and information models. But we feel that this is grounded in some in many years and even decades of research work on knowledge management, on machine reasoning, on how to build systems that draw conclusions from some abstract knowledge.
Yep, and to add to that, because of the same reason, they act as an enabler for integrating more AI and machine reasoning algorithms to the system. And to implement these closed loops now with new cognitive capabilities on top of these automated ontology models, so that becomes much easier.
Yeah.
Great. Well, thank you, everyone. I'm afraid we kind of are coming to the end of our time, which is a shame, because I know we could continue talking along this line. But Anand, perhaps you could finish with just some thoughts on why you chose this as one of the best papers from last year.
Yeah. I mean, after meeting the authors here, I understand why it got chosen, actually. So, because the kind of expertise that's brought together, as I said earlier. The other thing is, of course, the quality of paper. It's not only the authors, the quality of work. That's how it was judged initially. And then also the interest that we have seen in this paper as well. Yeah. So with all that, the paper was chosen as one of the best paper from last year. We really want to thank you all for having chosen this journal and submitted there. And also, I would personally like to congratulate all of you for the effort put and for the best paper. Yeah. Thank you.
Thank you.
Great. Thank you, Anand.
Thank you.
Thank you, everyone, for joining us today. And again, congratulations on the best paper.
Thank you very much.
Thank you.
Thank you.
Thank you. Thank
Bye.
you very much.